Hi, I'm Greg Staten, Distinguished Technologist for Color Science in the HP Displays Group, and I'm here to show you how to use the creator features that we built into the Omen Transcend 32 monitor. So let's open up the on-screen display by pressing the joystick on the back of the monitor. And I'm going to scroll down to open up the main OSD, and everything that we're doing is in the picture category. First thing I'd like to look at is markers. Markers are special purpose lines that are drawn on the screen that allow you to designate what is either protected areas of the screen or helping you compositionally on the screen. Enable markers, and the first marker I've turned on is EBU R95 Safe Areas. These are two squares that are based on a worldwide standard for where you should put all of your text information that goes on screen. Also sets an area to protect that you want to make sure that users won't lose information if their TV is overscanning. So the smaller of the two boxes is your safe title area. Any text that you want the user to view needs to be inside that box per spec. And indeed, if you're delivering to a broadcaster or an over-the-top provider, if you don't follow these rules, they may well reject your program. Another option that's available if you're doing closed captioning is the caption safe area. This area is a smaller region that ensures that your captions will go in a common standard reserved area. So these two options are very useful when you're designing subtitles or something else on screen. Subtitles should also go in the caption safe area. We also have some other options such as a center cross for compositionally. This is different from the overlays that you have for crosshairs on the gaming side of the monitor. And we have thirds, which allows you to compositionally break your screen into 9 equal parts. If you know the rule of thirds for composition, you can use these as guides for positioning elements. In addition to the broadcast markers, we also have aspect ratio markers, and these are enabled from the aspect ratio. We have the standard 185:1 widescreen and the 239:1 very wide, ultra wide aspect ratios. If you're composing for these cinema ratios, you can display these overlays. The nice thing about having overlays in the monitor is that they work with every piece of software you have. You don't have to worry about, I press play and my markers disappear, which happens with a lot of nonlinear editors. You can also change the color of your markers. We provide you with 7 different colors to choose from. Depending upon your content, you may find that one of the other colors is more suited based on what's going on in your content. The next group I'd like to talk about are the video level settings. These are very important if you're designing things for broadcast or for one of the over-the-top services, because televisions have different blacks and whites than a computer monitor. On a computer monitor, black and white are absolutes. There's nothing blacker than black and there's nothing whiter than full white. But on televisions, there is such a thing as blacker than black and whiter than white. The reason for this goes back to the old CRTs that we used to have, but this tradition has carried forward into the digital age. If you're producing content to go over the air or over the top, the black needs to be set at a higher level and the white needs to be set at a lower level. And if I choose limited range, the monitor will automatically switch into that mode so black and white are at the proper place, just like they would be on a television. Notice our first option is content controlled. Content controlled means that there's metadata that is signaling what the black levels are. Am I at video levels or am I at full range? Most television programming includes this metadata to signal to the television to switch. Because for example, your gaming console may not be limited range, so it knows to switch back and forth. TVs have gotten more intelligent. If you are working in post-production, this metadata has not yet been embedded, so you do need to manually choose limited range. You can also force full range. We give you both options so that you're able to work in any scenario you have. This is especially the case if metadata is present incorrectly. Now let's talk about Downstream RGB Adjust. This is a very purpose-built feature and is designed to allow you to tweak the output at both the black and the white level to match another device, such as a reference monitor or, in many cases, a projector. If you have the cinema projectors and you want to have this as a monitor that the artist is looking at in the screening room, you may need to go into Downstream RGB Adjust and change either the level of black for bias or, more likely, the gain for the whites to adjust. For example, some Barco projectors are slightly bluish in their whites. So I can come in here and compensate for that by lowering the red and green channels slightly. Notice that the values I have available are 10-bit values. This is designed to give me extremely precise adjustments. You typically don't make big moves here. You're making small moves, so using 10-bit values allows me to really refine in what I'm trying to do. It's important to note that this will not actually mess up the grayscale response of your monitor, even in HDR. It's just designed to help you to match to another type of device. The last one I want to talk about in the non-HDR options is Show Blue Channel Only. Show Blue Channel Only is for QC, and it's especially important if you are going to be working with highly compressed content. Because when you really compress content, you need to make sure there's not excessive macro blocking appearing. And the rule of all of the major modern compression algorithms is that blue is compressed the most. Therefore, by switching to the blue channel and playing back your compressed content, QC can check for excessive macro blocking. Very, very useful tool in certain post-production workflows. I want to briefly mention these last two options. If you're on a Mac, macOS ColorSync compatibility and Hot Plug Initiate are two wonderful settings because they allow you to automatically update Apple's built-in ColorSync, its color management engine for macOS, when you change color presets. So for example, if I go from Display P3 to Adobe RGB on a Mac, and these two options are turned on, the Mac will briefly dim either to black or to blue, depending upon which version of the M chip you're using. And then ColorSync will be synchronized. So now the Apple thinks, and any apps that use ColorSync know that you're in Adobe RGB. Note that for some applications, you may need to restart them because they only read from ColorSync on boot. Now let's talk about the HDR specific settings that we have in the picture menu options. There are two different HDR settings, HDR and HDR clipping level. HDR is very similar to the video levels. It allows me either to automatically be in HDR mode if the content signals that it is HDR. For example, if I were to boot up a game and switch HDR on in the game sends a signal that says this content is now HDR. The monitor sees it and automatically switches over to HDR. Similarly, if I put in a UHD Blu-ray and it's an HDR and I press play, that content contains that same signaling. But in post-production, you haven't embedded that yet. So if I'm working in HDR in post-production, I am in all likelihood going to need to turn HDR on manually. This says I'm in HDR, and just so you know, if your content that you're looking at is not HDR, it's not going to look right because HDR and SDR content are encoded completely differently as far as the levels are concerned. So turn this on if you're working in HDR and you'll see your content accurately. Probably you're going to do this when you're feeding a full screen output to your display. We also give you the option for HDR off, which forces it to ignore any metadata and not show it in HDR. This is also a very good feature for QC. There are a lot of UHD productions that are not in HDR, either because of budget, or because of creative decision, or because of the age of the content. There have been movies released into the commercial domain that unfortunately had HDR metadata enabled for non-HDR content. And if they had had this monitor, their QC could have checked it and saw, well, the colors look like everything's on fire. This isn't right. Switch HDR off and go, oh, it looks right now. We have a problem. That metadata that isn't supposed to be there was embedded. So again, a really, really great QC function. Now let's talk about HDR clipping level. The reality of an OLED monitor is that you're always power limited. That means that as you brighten up a pixel, it is drawing more power. If I try to brighten up the entire screen, I can hit my power limit if I try to brighten everything, for example, up to 1000 nits. It just can't do it, okay? OLEDs are evolving and they're much better now than they used to be, in that we can get more pixels bright, but we still have these limitations. If I set it to 1000 nits, this allows the monitor to get to up to 1000 nits of brightness, but only for a 3% box or average picture level. In other words, only 3% of the screen, like a pinpoint, can be at 1000 nits. And that's actually a fairly big box if you do the math. It's about this size. In an OLED monitor, as my spot size grows, I am automatically going to start clipping the scene, and the brightness is going to, max brightness starts lowering. If I want to make sure I see accurate for a certain point, I can set it to 450 nits. This allows for up to 10% active picture level to be at 450 nits or brighter. Again, if it becomes brighter than 450 nits, it is going to dim again. And that leaves us to the final option, which is 250 nit full white. This is the brightest we can make the entire screen. The good news is that most HDR content is well below 250 nits. Indeed, the nominal brightness for virtually all HDR content that's been made up to this point is between 100 and 150 nits. So you should be just fine for the majority. But again, if you need to crank up perspective highlights and see it that bright, we give the artist these control point options. So you know what the capabilities of the display are for brightness at any given point in time. Since we've talked about HDR and the capabilities of OLED, I want to move over to the system options because there's some OLED protection features I'd like to talk about. These are very important features that help us maintain the life of your OLED display. The good news about these is that the defaults are probably just fine for 99% of the use cases out there. But I want to briefly talk about what is available. The first one is static screen detection, which is on by default. This is designed to dim the screen if it is static, meaning no pixels are changing, for about 30 seconds. What we'll do is we'll dim the screen down about 30%, wiggle the mouse or something changes on the screen and it instantly pops back up to full brightness. But this is designed to keep things from burning in that are very bright, just sitting on the screen. We recommend you leave this on. There are some people that prefer to have it off. That's why we give you the option. The next one is lower third detection. I like to refer to this one as the broadcast 24-hour news channel option. The reason for that is that these broadcast news channels all have across the bottom third of the screen, or in the bottom third of the screen, some sort of banner that contains, for example, comment on the story they're talking about or information about what's happening. There could be weather, there could be a tracker showing sports scores or what's happening in the world. Those things tend to be bright and highly saturated. If you turn lower third detection on, it is going to detect when those are present and dim and desaturate just that portion of the screen very slightly. This was originally designed for televisions, as you could well imagine. And if you go to Artings, you would see that their classic "How does OLED burn in badly?" is watching these sports or news channels. The third option is letterbox and split screen detection. This is designed to deal with a specific issue when you're watching letterbox content, such as widescreen content, cinema widescreen content on a 16:9 monitor. At the transition between that black bar and the active picture content, there sometimes can be some high frequency information that can cause a visual artifact with OLED. If you turn this option on, and it is one that we have on by default, what we will do is we will slightly reduce the brightness at that transition point. It's only a few pixels wide, but it is designed to accommodate that problem. Similarly, if you have split screen content on two sides of the monitor, it addresses that as well. The fourth option is called Pixel Refresh, and this is the most important function to keep your OLED monitor from burning in. This is an automatic function that you can choose to run manually if you want by essentially pressing in the joystick with this option highlighted. But let's talk about how it runs on its own. As an OLED is used over time, it builds up a charge that can introduce burn-in. We have to reduce that charge by using this refresh function. After about 8 hours of continuous accumulated usage of your monitor, we will bring up a message that says, you're getting to the time where we need to do pixel refresh. Would you like to run it right now? Well, it may not be convenient for you to run it right then and there. You could say, no, defer for later. At that point, we are going to start a second timer that runs for 4 hours. If at any point during that 4-hour period, you either turn the monitor off by pressing the power button, or it goes to sleep because the computer issued a go to sleep, we will run Pixel Refresh, which takes about 7 to 8 minutes to run. When it's running, the LED that we have down here in the bottom of the monitor will be flashing about 1 hertz to indicate that we are doing a pixel refresh. The screen will not respond and will stay black throughout the entire refresh process. Now, if the entire 4 hours has happened without you turning off the monitor or without you going to sleep, we will have to force Pixel Refresh to run. And we'll bring up a dialog saying, I'm sorry, we're gonna have to start Pixel Refresh. At that point, we will take over, and it's unfortunate, but again, this is a critically important feature to keep running. There's one more option that is not available as a selectable mode because it's always running, which is known as pixel shifting. This screen is actually 8 pixels wider and 8 pixels taller than the UHD 3840 by 2160 raster. Very slowly, we are shifting the entire image in a random pattern through those extra 8 pixels horizontally and vertically. You can't really see this, but it does very slowly orbit around, which means that any static images, such as some of the things on the Windows taskbar, will be moving around and won't be sitting in one position, which increases the risk of burn-in. For more information on the Omen Transcend 32, go to support.hp.com. Thanks for watching.